All right, we are starting Unit 4, which is all about iteration. So obviously the first thing we do when we talk about iteration is talk about loops. And so we're going to talk about three different types of loops, or maybe two, depending on how you look at them. But loops in Java, they're going to allow us to iterate over, a whole bunch of different things. Later on, we'll use these a lot in terms of arrays, which we haven't learned about yet. We could iterate over a list or a set of data values, or in this case, we're just going to do something a whole bunch of times, which you'll see here in a second. So the first loop that we're going to talk about is what I would consider to be the most basic of loops, because it only has one value that it kind of takes in and uses, and then the rest is up to us as far as how we want to set it up, and that is the while loop. So as you'll notice when I type in while into Atom here, immediately is purple because while is one of the reserved words in Java, because Java knows what it's going to do, and this is going to be a loop. So what goes into a while loop, or what they look like in general, is I'm going to have something that goes in these parentheses, and I'm going to have something that go into these braces. What goes into my parentheses is what we're going to call the control expression. And what it does is, and I'll put that in there right now, control expression. The control expression is something that we are testing. So what a while loop does is that it continually does something, whatever's inside while loop. Whatever's inside my while loop, it will continue to do that, and every time it does that, it will test my control expression to see if this is true. So in other words, my control expression is a Boolean expression. I will always test to see if it's true or false. If it is true, then I will continue to do whatever is inside of here. I'll continue to do that over and over and over and over again until my control expression, or my Boolean expression that goes into my while loop, is false. So that's the general idea of what a while loop is. So let's do something just really basic. Let's say we want to print out the numbers 1 through 10. So I'm going to go ahead and do that. I'm going to need a variable to print out. That variable I'm going to have to create outside of my while loop for a number of reasons. Number one, that's just how we have to do this one. But number two, it's worth just reminding you of the fact that there's this thing called scope. The fact that if I define variables inside of my while loop, they will not be useful to me elsewhere. They are just locally defined. And so once I leave that while loop, they no longer exist. So what I'm going to do is I'm going to create just a variable to count with. A lot of times we will very commonly use the letter I, just because, I stands for index, and it's something that I can loop over many, many times. So I want to print out the numbers 1 through 10, so I'm going to set I to be 1 to start off with. And then what I'm going to do in here is I am going to print out what I is. So system.out.print line, and then let's just throw a string in here. The number that I'm currently looking at is I. Nope, it's my 1. I. Perfect. Okay. So let's think about what's happening right now. I don't have an iteration, or not an iteration, but a control expression here quite yet, but I'm going to do that here in a second. But what now is going to happen is my while loop is just going to continually print out number and then I. But you'll notice I'm not doing anything to it. And so I have to increment I by something. So it's a question of where do I want to put that. And the answer is I want to put it, I think, after my print statement. What you're going to notice, and what your issues you're probably going to run into a lot whenever you're working with while loops, are these off by 1 errors, and just the placement of what we're going to refer to as my iterative step, or my incrementing step actually is what I want to say. My increment step after versus before is important. So what I want to test, well, I want to keep printing things out as long as I is less than, so I want numbers 1 through 10, less than 11. Okay, so what's going to happen here is I'm going to start off my value of I is 1, and I'm entering this loop, and I'm going to ask, is 1 less than 11? The answer is yes. And so I will print out that number, and then I will increment I by 1. So now it's at 2. And I'll go back to my loop, and I'll check to see if 2 is less than 11. It is, and I will keep doing this over and over and over and over and over and over again until I get to, so once I is incremented to be 10, it's still less than 11. I'll print that out. And then I'll increase I by 1, so now I is 11. Then when I go and check to see if this is the case still, the answer is no. And so I'll exit this loop. And so I can go and check that real quick. So Java compile. This is fun with didn't save. Oh, I'm not in the right folder. Unit 4 that we're on now, Java compile. And then this is fun with loops. Marvelous fun with loops. Awesome. So now I have the numbers 1 through 10. Great. So obviously I can just count things, no big deal. Let's do something that's just slightly more interesting. What if I want to print out numbers that are just multiples of 5? A couple different ways that we could do this. One thing that I'm going to do, so numbers multiples of 5 that are less than, let's say less than 100, but not including 100. So what I'm going to do is instead I'm going to start, this is 0, because 0 is a multiple of 5. And I'm going to print out the number, but I'm going to change my increment step here this time. I don't want to go up by 1 every time. I'm going to go up by 5. And like I said, there's a couple different ways of doing this, but this is just one. So plus equals 5. And then I'm going to go until, okay, so I want the numbers or multiples of 5 that are less than 100. So I'm just going to make sure this is always less than 100. Perfect. Okay. This, I think, is the most straightforward way of doing this. I'm going to show you another way of doing this here in a second, which is just as good. Or maybe it's slightly less as good, but nonetheless. Okay, so now I print out all my numbers 0 to 95, all numbers less than 100. Awesome. How could I have changed this and done this differently? Well, so in this case, what I'm doing is I'm incrementing by 1. Let's say I just wanted to, or incrementing by 5. Let's say I just want to increment by 1 every time. So what I could do instead is put an additional if statement in here and check to see if I is a multiple of 5. So if I mod 5 is equal to 0, then I want to print out my number. So the reason I'm pointing this out to you is that this is, of course, a valid way of doing this. It's just fine. However, it is going to be, in the grand scheme of things, or I guess in the, yeah, no, I won't say in the grand scheme of things, for larger values, is going to be slightly slower. So it does exactly the same thing. But here's what's happening is now how many values did I test the first time? I tested essentially 21 values. Now I'm testing 100 values. Or I guess 101 values. And so when we're running this with just these small sample sizes and small numbers, I mean, the running time is basically instantaneous anyway, so it doesn't make a big deal. But what if I was testing, 2 million numbers or something like that? Obviously, it's going to take just a little bit long. In fact, you would make the argument it's going to take about 5 times as long. So it's worth noting that, especially when we're in loops, things can get out of hand pretty quick. I just want to make sure that I am doing things in the most efficient way possible. Okay, so this is fine. And if I went back to plus equals 5 and got rid of this part, actually I want this part. Save this, Control X, get rid of this, goodbye. Okay, so now let's say I gave you a different situation. I want to find all the numbers that are divisible by 3 or 5. Well, actually, my previous version is the only way that I can really do this, because I would have to check to see if the number is divisible by 3 or if the number is divisible by 5. And I can do that as well. So I can have compound Boolean expressions in here. So let's actually bring that back. So if I mod 5 is equal to 0 or I mod 3 is equal to 0, then I would like to, I guess I got rid of this, print line and then number I. Perfect. Okay. And this should, I need to change this, should give me every number that is either a multiple of 3 or multiple of 5 that is less than 100. Let's confirm. Wonderful. Just quickly skimming through, it looks like this is just fine. All right. Let's look at one other version of while. So in this case, I'm starting at 0, which is fine. But if I started at a different number, actually starting at a whole bunch of different numbers would be fine. I could start at -1, I could start at 1, I could start at 2, and they're all going to give me the same output, right? But let's say I wanted to create something that I could, if I give you the number 100 here, it'll, and I run this, well, what's going to happen? Well, nothing, right? Because I test to see this value is 100, and automatically it's going to fail and it's not going to do anything. So let's say I always want to print something out. At least give me the number that I'm starting with. How can I write this differently? And the answer is I have a different type of loop, and it's called the do while loop. So it looks like this. So do, and then I have my brackets, and then I have while, and then I have my control expression, and this is the thing that always gets forgotten, semicolon. So if I want to do this exact same thing that I did before, let's change this back to 0, and 0, and I want to, okay, so what did I have before? Let's just do the multiples of 5. So if mod 5 is equal to 0, then print out that number for me, please. Print line, number, I need a string, number, and then I. Okay, wonderful. And then, of course, you need to increment each time. So this is not the most efficient way of doing it, but it's going to prove some points for me here in a second. And then I need I to be less than 100. Yeah, okay, this is good. This is everything I want. Let's just go run this, make sure it works the way that I want it to. Marvelous. 0 is my first number, 95 is my last number here, because I was trying to get numbers less than 100. Okay, so what the do while loop does for me is that if I wanted it to, it'll always print out this first thing, even if it does not pass my control expression. So for example, if I change this so that my starting value was 100, well, what's going to print out now? Well, I'm going to go ahead and test 100. Is it divisible by 5? And the answer is yes. And so it'll print this out, and then it will test. And so basically you're just getting rid, or not getting rid of, but you're adding one additional potential step here at the beginning, which is that, I always run the loop at least once automatically. Otherwise, everything after that is basically exactly the same, because I'm going to run this while loop no matter what. So this is not something, so it's worth noting that the do while loop is out of the scope of the AP exam. However, it's something that comes up every once in a while, and so it's just it's something that's worth being aware of, even though, for being honest, probably doesn't get used a ton. I would bet you that most people, if they had to write some type of loop and guarantee that it was going to run only at least once, they're probably going to write it in a while loop or the other loop that we're about to learn about here in a second, and then just have like copy and paste whatever is inside their loop outside of their loop so that it does it automatically once. Do while loop doesn't get used a ton, but it's worth knowing that it exists. Okay, so let's do this everything that we just did, but let's do it in our other type of loop, which is called the for loop. So here's what a for loop looks like. For is what it starts with, and then there are 3 components to it. So 3 things, and we'll see what those look like here in a second. And then, of course, I have my braces, which actually, this is what's being done on the inside. Okay, so there are 3 parts to my for loop. The first part is what we call, or what some of us will call, the initializing expression. My second part is the control expression again. And then my last part is the what some of us will refer to as the step expression. I'm going to give you maybe some better words for these here in a second. So there are 3 parts to my for loop, or into this initial line of my for loop. The control expression is exactly what it was like in the while loop, where this is the thing that I'm testing every single time to determine whether or not I would continue on in my for loop. The initializing expression is something that gets run once. It doesn't have to be an initializing thing, but generally speaking it is. So if I want to create a variable that's just going to be used within my for loop, because if I create a variable inside my for loop, it's going to lose scope afterwards. But if I want to create something that's just going to be used inside my for loop, then I can do it here. And then my step expression is something that will get done every single time. So here's what typically happens. So if let's rewrite what we just did, which was print out the numbers 1 through 10. Here's what it would look like in a for loop. It's going to be a little bit more concise. I'm going to start off with that variable. I'm going to initialize it here. So integer I equals 0. And what this will happen with this is it'll get run exactly once, and that's it. Right at the beginning of my for loop. What I want to do is I want to print out the numbers 1 through 10. So I is less than 11. So this is my conditional. This will get checked every time, my control expression. And my step expression is something else that will get done every time. So in this case, I want to increment I. It's where we typically put it. Now, if I want to print these things out, just like I did before, I'm going to throw my printout statement in here. So in this case, number is, and then what I is. Okay. So most basic of for loops here. I'm going to go ahead and run this just to confirm. And there I go. I have my numbers 0 through 10. Oh, I started at 0. 0 through 10. Exactly what I wanted. So let's point out a couple things. Number one, what happens if I try to, why am I typing it again? What if I try to see one more number? I want to see one more number here. So I want to, what should this be? Well, afterwards, I increment to 9, and I'm good. I increment to 10, and I'm good. And I increment to 11, and I run in here, and I find out that this fails. And so I will exit my for loop. So if we put a print statement out here at the bottom, what I would expect to have happen is to print out the number 11. Well, let's see what happens. All right, so like we just said, maybe a couple minutes ago now at this point, is that Java tells me it cannot find the symbol. And the reason for this is because it is out of scope. Where was I created? It was created inside of my for loop. And so outside of it does not exist. Well, so and this is my issue with calling this the initialization step, is that it doesn't always have to initialize something. I could change it to be this. So let's do it slightly differently. Let's say that we created a variable up here, I, and it's equal to 100. The point being is that what's done right here will get done once at the beginning of my loop. And so even though I initialized I to be 100 up here, it'll immediately get reset to 0 just that one time, and then we'll run through the rest of the loop just like normal. But now, since I create I outside of my loop, where is it available to me? And it's available outside as well, which is great. So if I go and I try this again, and I will see that I'll print out the numbers 0 through 10, and then that bonus one, number 11 at the bottom. So the other thing that's worth noting is that I actually don't require well, actually not just this one, but any of them, I guess. So let's say I want to get rid of this here at the beginning. If I have no initialization step, if I want I to start at 0 and I do this out here, that's fine. I can do that. It'd be, I don't know, kind of a waste of space, I guess. But this runs exactly the same way as it did before. I don't need this initialization step. In fact, and I don't know why we would do this, we just go ahead and get rid of this as well. We can get rid of our incrementing step here as well. So if I want to, okay, let me see, where am I at? So if I want to increment I inside of my, let's get rid of this, inside of my for loop, I can do that as well. And you can see that this will, oh, that's not what I want. I will, where is it? There we go. I can compile and run this. Exact same thing, except I got rid of that one line. In fact, and I don't know why I'd want to do this, but I can get rid of my control as well. Now, what's worth noting, okay, let's, first off, what do you think is going to happen if I get rid of this altogether? And the answer is, did I say if I did? All right. compile and run. Well, so now I have no control here. It's just gonna keep going infinitely, right? And so I'm already up to 100,000 ish. The one thing that's worth noting is that the computer seems kind of slow. Like I've only counted to about 350,000 now at this point. It's worth knowing that what's actually slowing down the computer is how quickly it can print these out to the screen, right? If you just ask the computer to run through, we're at 500,000 now, different values. If you just ask it to run through those, like it would do it almost instantaneously. Printing to the screen takes a while though. Anyway, when I took out that control statement, obviously it's just going to keep going and not stop. And this is what we call an infinite loop, right? If I screw something up with my test case or something along those lines, then I can run this problem pretty easily. And so it's worth noting, if you want to stop it, Control-C breaks the loop and stops it. So, or it actually just breaks the program in general. So how could I write this differently? Well, there is actually something that we have at our disposal, which we've seen one time before, specifically when we're talking about switches. But if we wanted to, we could write in here, if I is greater than 10, so we've made it past 10, we have this statement. If you remember what the statement does, the statement is break. Break gets us out of the loop that we're in. So if I go ahead and do this, if I go and run this, there we go, numbers 1 through 10, or 0 through 10. So I can get rid of all these things in my for loop, like the initial statement there. Why would I ever want to do that? I don't know, but I can, and that's just worth noting. Okay, so let's see if I've talked about all the things I want to talk about. I've got that done. That was fantastic. Yep. Let's talk about some examples then. Let us do, we already did the infinite loop. Okay, let's do something slightly different. So let's say I actually want to calculate something. Let's say I've got a job, and at that job I make payment, or how about wages? At that job, when I first start it, I get $40,000 a year. $40,000 a year. Yep. My question to you is this: what's a good time to work at a company? After 30 years, 30 years, that doesn't seem right. After 40 years, how much will I be making if I can expect a 3% raise each year? So think about that for a second, and I want to print those all out. So I don't want you to just calculate it once, because if I just calculate it once, then that's not interesting, right? Here's one thing that's worth noting about why loops are so important for us. Everything we've done up to this point is basically one-to-one with lines of code and then what we do, right? Everything we've done up to this point is every line of code that we write can do something, but again, it's one-to-one. You know, I'm not really saving much time, other than the fact that I can run the program over and over and over again. But I'm not really saving much time because it's this one-to-one relationship. Loops, what they do for me is make this 10 to 100 or 1,000 or billion times to one relationship where I can write a line of code once and ask my loop to do it, a billion times. And so that's the power of loops, is that really expands on just how we can execute things and how quick we can do things. Anyway, so point being, if I just asked you to calculate what my wages would be after, how many did I say, 40 years? You could just do that. We could just take 40,000 times 1.03 to the 40th. I want to know what I'm going to make each year. So go ahead and pause the video and try that out. Okay, so this is what's going to look like. I'm going to, let's see, so I don't have to create anything here because I have my starting value, my wages, so I don't actually need to change anything. I'm going to increase, so I said 40 years. Oh, I do need something. I need my years. So what year is it? I'm going to start at year 0. So integer I equals 0. Year 0, I make $40,000, obviously. And so after 40 years, we'll go ahead and just say in my 40th year. So while I is less than or equal to 40, and I want to increment I each time. All right, so what I'm going to do is I'm going to reset wages to be equal to wages times 1.03. And I'm just going to print that out. Send that out, print line. And what I'm going to say is in year, I, comma, I will make, and then my wages, period. Okay, that seems pretty good. Okay, so in my loop here, let's just double check to make sure I'm not going to have an off by 1 year here. Starting at 0, year 0, I want 40 years past. So this will go all the way up to 40 because I have my less than or equal to. I plus plus, make green by 1 each time, multiplying wages by 1.03, and then printing all out. I think this looks good. Go ahead and run it. Oh, what did I screw up? Unexpected, where's my semicolon? Maybe it would have made more sense for me to actually read what it said. Funds loop error, line 8. This is embarrassing. Okay, so I'm missing the, good golly, I'm missing a plus. Okay. If that would have taken me any longer, it would have really, it's kind of embarrassing as it was, but it took me, I don't know, whatever. We've moved on. All right, here we go. So in year 0, I will make, that's not exactly what I want. So that is an off by 1 error. All right, how can I fix this? Really easy fix, right? I just want to print before I make my adjustment. Perfect. Okay, one more time. There we go. All right, so in year 0, I will make $40,000, and then that will continue to increase until I make $130,000 in year 40. All right, not too bad. Power of exponential growth, of course. All right, let's change the problem slightly. Let's say I'm curious to know how many years would I have to work to make $200,000? Well, so it's worth noting that I don't have to use I here. I can use a different variable in my control step. So what I can do instead is I want to figure out how many years it's going to take. So I can test to see, keep running this until wages is, or while wages is less than 200,000. All right, so I can use a different control variable here, and that is just fine. And so I do the same thing, and it looks like I'd have to work for 54 years at this job. But I want to give me one more. I know the answer is gonna be 55, but all right, how can I do it slightly differently? Well, again, I could. No, that's not gonna happen. That's not what I want. I feel like it's kind of cheating. This is fine. This will tell me exactly how much I'll make in that last year. Oh, no, it won't. No, it won't. Oh, because I don't know what I is. Oh, darn. Okay, that's fine. It's fine. Fine, we can fix that. We can fix that as well. I equals 0. Perfect. See, aren't they just wonderful, teachable moments? Perfect. All right, so in my 55th year, I will make $203,000. Marvelous. I only have to work 55 years to get there, though. Not a big deal. I can do that. All right. Let's see. So we've talked about while loops, talked about for loops. One more example. One more example, and then I think we'll call it. We need to talk about continue. All right. Here's one more example. Here's a good one. I like this one. Let's say that I want to, if I give you a digit, or not a digit, but a number, and that number is number equals 473,821. I want to know what the sum of the digits are. Okay, so think about part pause the video and think about how can I use a loop to tell me what the sum of the digits are of that number. But it could be of any number, like whatever they happen to put in. So go ahead and pause it and try and figure that one out. All right, so here's how I'm going to do it. And it takes a couple of clever things, like clever Java things to do here. So I have a for loop again. I'm not sure quite what I'm going to iterate over. Here's what I'm going to do. So essentially what I want to do is I want to get one of the digits and add it, like save it somehow. So in other words, I'm going to need a sum, probably, that'll start at 0. So what I want to do is I want to add the digit each time. And it's okay to rewrite over number. I don't really need it. So what I'm going to do is I'm going to ask for it to say sum plus equals. Then I just want that first digit. How do I just get that first digit? And the answer is modular arithmetic. If I ever just want to get the first digit of a number, I can always make it number mod 10. So number mod 10. Great, wonderful. But now I've taken that number off, which is great. How do I change this so that that number is kind of eliminated? And the answer is I can use integer division. So if I'm clever, what I can do is I can say number, I want to divide it by 10. So divide equals 10. What that does for me is, since it's integer division, basically just like lops off that last digit, moves everything down by 1, but then cuts off what's past the decimal point there. So perfect. Okay, so how long do I want to do this for though? I want to do this while number is greater than 0. Yeah. So I have nothing to increment. I want to go until number is while number is greater than 0, and I don't need to increment something every time. I guess I could just done this in a while loop. In fact, I am going to, because it looks kind of gross whenever I have the semicolons in there that are weird. Okay, perfect. While number is greater than 0. Marvelous. Okay, so in this case, what I should get, 11, 14, 22, 24, 25, 25, 25, 25, 25, 25, 20, nothing, because I didn't print it out. That was dumb. System.out.print line. I want to print out sum. Perfect. All right, 25. Is that what I said? Was it 25? We'll find out. 25. There we go. Awesome. Okay, cool. So that was a good one. Okay. There's one thing that I skipped over that I want to talk about real quick, and that is continue. So let's go back to that that example where I was printing out multiples of 5. So in this case, what I needed was some number that is starting off at 0, and then I need a while loop. And so I want to print out the multiple 5s that are less than 100. So while number is less than 100, I want to print out multiples of 5. So what I'm going to do is, and this is a totally convoluted way of doing this. If number mod 5 is, all right, wait for this, not equal to 0, what do I want to do? Well, I can tell you what I want to do if it is equal, or mod 5 is equal to 0. So what I want to do is system.out.print line number, let's just print out number. That's what I want to do if it's not. So how can I do this so that, and again, totally convoluted, it's a dumb way of doing it. But what I can do here is, let's say I want to have something where I've already done everything I wanted to. Let's go ahead and skip to the end of this loop. And that the answer is there's this keyword called continue. that what it does is it says that if I ever reach the word continue in a loop, what I would do is I would skip over the rest of the code in this loop and just skip to the next iteration. So I got to be careful here, because what I haven't done yet is added in my increment step. Normally, what I had last time was I had in here number plus plus. Okay, so what I just told you about what continue does, what would you expect to have happen? And the answer is not exactly what we want. So I'm going to start off with number 0. I will, if number mod 5 is not equal to 0, okay, which it's not, so it is equal to 0 currently. So I will system.out.print number, and then I'll increment number by 1. Okay, so now number is 1. And I'm going to go back up here. While number is less than 100, it is. If number mod 5 does not equal 0, so 1 mod 5 is 1, that does not equal 0, perfect. I'm going to hit continue. And what's going to happen is it's going to skip over the rest of this and then immediately jump back up here. And the issue is that I will get myself in an infinite loop because I will keep continuing until I get back up here to this while loop. And so I have to be careful about where I add my number. I got to make sure that my increment step is always before my continue. So if I put it here, now I will increment by 1. So this is going to not print out the number 0 for me, which I don't feel that bad about. Aha. And I get 100 in there as well, which is fine. But what continue does is, yeah, it skips over the rest of the things that are in this loop. So, don't quote me on this, but I'm pretty sure that break and continue. I know I'm like fairly confident continue is. I'm less confident that break is, but don't think that continue is within the scope of the computer science A exam. I don't think break is either. But I think that they kind of note that like it's worth knowing. But I think they're both worth knowing, just because again you might see these, they might come up in someone else's code, and you should be able to read it. So that's all to do with loops. Okay, we are, how far am I into this now? I don't know, several minutes, 37 minutes. And so that was a real brief introduction. There's a lot of good problems out there that you're just going to have to experience kind of working with loops for, because it just takes this different mindset of being able to think iteratively and think about how to go over these different values, because obviously when I write this code, I'm not thinking about the 100 occurrences. I'm thinking about a small number. Okay, what is it going to do for like my edge cases? What's it going to do with 0? What's it going to do with 1? I get up to 5, think about what's going to do there. But being able to think through these problems is a super important skill. So this is just a starting point for loops, but it's going to lead into a whole bunch of more powerful things that we're going to be able to do with this later.